Like the first one didn't save correctly, and then like when I was using online GDB, it wasn't working. Like I don't know.
I'm telling you, you know, and you took my class last semester. I'm like, what's she doing? What's
I don't
going?
know what I did. Okay.
But
do you know what I did?
I do know one thing in the header. You did just header, not header.h.
But when I did that, it wouldn't work.
But okay, this is another thing I saw.
Yes.
When you loaded header in the main program, but you also loaded header.
Well, that's because I said that like when I had to redo it to save it, so I could upload it to Canvas, I didn't delete everything.
No, but
but that's why it was in the program, because I didn't delete everything.
But it's supposed to be in the program.
I know, but I didn't type it in there to begin with. Like I wanted to delete everything to copy and paste over the other side.
Right. Yeah, and it just happened to stay.
Yeah, because I didn't finish deleting it.
Okay.
So.
All right. I'm like, man, what?
No, I did not purposely put that there. No.
I'm like, what's she doing?
When I saw that, I was like,
I'm like, man, I tell you. And all those other people with those zeros. Class, you're not gonna make it, I'm telling you. When it comes to the end of the semester, you're gonna like, man, if I only would have done this, or got points for doing this, my grade would have been uplifted. But zeros is just zero. You understand? So and that hurts your grade a lot. Alright? So in my class you got to do your assignments. You know, it's hard to pass without doing assignments. I'm gonna just pass the test. You're gonna come up real, you know, close to either being over that line of making a C or just doing, you know, failing the class. So you got to do the assignments, and I can't stress that enough. So hopefully everybody kind of pick up their game. Because you had almost 2-3 weeks to what? Download the software. That's the first thing you should have did. First day, boom, download the software. Let me download this, get it done, or whatever. Go to Mr. Sylvester. Hey, having issues with this. Hey, what's going on here? Why is this going on? Okay, I got it. Now I can get started with my program. But that last minute stuff, man, that's tough. It's hard. It's real hard. But like I say, I can't make you do it. It's up to you to do it. All right. So, let's complete our notes, and then remind me I'm gonna post the test. Yes.
Y'all gonna get this done right now?
When you gonna do that after class, right?
No, I was gonna do it now.
So they're in the meeting, so you won't be able to stop. Yeah. So we'll do it after class. All right. So now, let me get this up. Okay. Okay, so let's continue with our notes.
We stopped on programs and programming languages.
Program what?
We stopped on programs and programming languages.
Okay, and that's normally here. All right. So we kind of discussed the various programming languages, and that's not all of them. This is just a few that they do have. All right. Now, and if you would know, well, you haven't programmed in them, but as you would learn these different programs, you would understand that some of the techniques and features in them are similar. You understand? It's not exactly the same, but you know, somewhat similar. All right. So we talked about these. Okay. Now, source code, object code, and executable. The source code would be what, class?
Source code.
All right, when we type our program, right, in the compiler, that's our what? Source code. So that's the program that you type. That's your source code. What happens is then you execute or you compile it, and it creates object code. Because once you get all the syntax errors, So that's a new word, syntax. So what is a syntax error? Anybody? It's an error on a command or a line or the way you type something or whatnot, right? It's not a logical error to where it's like, oh, I added something before I was supposed to, before I divided. You understand? That's logic.
It's the little errors you get when you run the program. That's the
syntax, correct, right? Because logical errors, the compiler cannot detect because it doesn't know what you want to do, right?
Right.
So it compiles and it get object code, which eventually is converted into executable code, which is our what? Program is our machine learning, right? Okay. So that's what happens. All right. That's how the compiler works. Right? And now you're just talking about C++ and the steps in the compiler, etc. We kind of talked about what happens. So, but what happens is, and we don't really see it. I think I showed my one of my classes before. When we write a program and we compile it, and it compiles successfully, we actually create a .exe file. Okay. That's a file that you can have and put on any system that runs an executable file and just execute that file and it should run. You wouldn't have to go in the compiler, compile it, and run it. You just execute that executable file. All right? So that's what you're actually doing when you compiling a program. You're creating an executable file. All right? So here, it's telling you what happens when you actually generate that code. All right. So you have your source code, which is actually entered into a preprocessor. You may modify the code. All right. But then it's compiled. Once all the errors out, it's compiled, and then what? You get the object code. Then that object code is passed through a linker, which creates the executable file. Okay, so that's what happens. So this little program, any program you write, pretty much have to go through this process. All right, whether it's large or small, they still have to go through that process. Because what? The start is what? Source code. The end is what? Executable code, which is machine language. Right? All right. So now we're talking about IDEs, which is Integrated Development Environment. Visual Studio is an IDE. Online GDB is somewhat of an IDE. It's a lower, watered down version of one, but in a sense it's still one. What? You got the editor, you can add files in it, execute files in it, all in that same application, right? And online GDB, Visual Studio is basically the same thing. And it says these environments consist of text editor, compiler, debugger, and other utilities that's integrated into the package to assist you in writing the code. Now, many of you who did your assignments, right, Mr. James, those who have even attempted to do their assignments, notice that when they type it inside of these compilers, nowadays these compilers are somewhat smart because when you type, like say, C out and you put something in double quotes, it color codes it. You got what I'm saying? So you can look through the program at times and see what's going on where as you get familiar with it, right? So, like I said, color code something if you're doing, say you're doing loading a library file, a certain color. So you can see what's going on and know, hey, I must have an error here because it's not the right color. So if you learn the compiler and learn this color scheme, that'll help you in writing code too. But you know, some people back in the day, all you had was a flat text editor, like Notepad, and you just had to type your code. You didn't know what was what, how, what, whatever, until you got back to error, right? But now they're a little bit smarter. All right? But that's all an IDE is, all right? It's an environment where you can do pretty much all of your work within that one application, all right? All right, so this is the end. Is it? No. All right. What is a program made of? Program is made of many what? Different what? Statements, right? The statements in a program. All right. There are certain elements that are common in all programming languages. All right. Most programs, well, we know that you have sequential. You can write a code that's sequential. You can write code that's where you have the loop, and then you have the condition, right? Where you have asking a question. And as you write larger programs, all of those are encompassed within each other at different times. All right? So, here we go. It says all programming languages have a few things in common. All right? The table 1.2, which is down here, all right, lists common elements you'll find in almost every program. Now, keywords, okay? All that's saying is when I'm in C++, there are several words that are understood by that compiler that I can't use for my benefit as a programmer. If, for instance, creating user variables or whatnot, I can't use if. I can't use cout. I can't use main. You understand? Those words are already reserved within that application or that compiler for a specific purpose. All right? So that's what keywords are. So when you move to another application, then you may have added keywords. You understand? It might be other words that application used that C++ may not use. So you have to learn that application. All right? Then there are programmer-defined identifiers. Those are pretty much, and in short, for the simplest term, would be variables. All right? But you know, we can have what? We can create modules, you understand? File names. We can come up with identifiers ourselves. Now, so to create an identifier or a variable, what are some of the rules? What's one of them? For creating a variable. A variable cannot, variable name cannot, no space. It should be one word. What else?
No.
It cannot begin with a number. Now this is C++ rule, right?
Right.
All right. Cannot have spaces or must be one word. Cannot begin with a number and
Capital letter. He said case sensitive.
What? No special characters, $, commas, double quotes, single quotes, apostrophe, all those things can't use in a variable name. All right? So, example, if I told you I wanted you to write a program to store the number 100 into a variable and then print that value out, you got me? How would you declare that variable?
You have to type out the...
So like say we do int. Int what? What name you would give that variable? That's gonna store 100 in it. You can call it number if it's all one word, right? Can number be can number be all uppercase? Huh? Yes. Can number be in uppercase and everything lowercase?
Yeah.
Can number be capital N, lowercase u, capital M, lowercase b, capital
E, lowercase R.
Yeah, lowercase r. Can it be that? Yes, that's called camel case. You know, like the hump in the camel. On the camel case, you can do that. So remember the letter A, the value in the decimal value is what? 65. The lowercase a was what? I think 97. Remember? So capital A and lowercase a have two what? Different values, right? And C++ is case sensitive, right? So if I create a variable called, say, number, all lowercase, and then further down in my program, I'll try to say number, capital N, and all the rest lowercase is equal to 5, what's gonna happen? You'll get an error saying number with the capital N is not declared. Okay? Because it has to match your declaration. Right? Alright. So that's another thing that programs have in common. User-defined identifiers. Now, other identifiers, when we start writing code later on in the semester, we're going to create our own functions. We know main has to be there, right? Main is a function, but we can create functions. Those functions that you create as a programmer has to follow the same rules as a variable name, right? No spaces, can't begin with a number, and no special character, right? Same rule. Anytime you create some type of identifier, you have to follow those rules. Now, some applications have a limit to the length of a variable name, but hopefully we don't run into that because sometimes it's like 65 or whatever, so we don't really go that deep into creating names at this point. All right. Also, operators. All right. So what happens when we deal with multiplication expressions? What can we do? The simplest ones. The 4 we use. Oh, we got 5 though, but the 4 we use. Adding, right? All compounders do that. Subtraction, multiplication, division, right? But in C++, we got one that we can use, which is called a what? No, that's with the math. But what's that other one we use? The percent sign.
Slash.
Y'all forgot from last time.
That's a remainder.
That's what it does, but what's that called? The modulus. Remember?
I was thinking about
So C++ has the modulus function, which returns the remainder. Example. What's your name here? Miss what? Parnero.
Parnell.
Oh, Parnell. Oh, I'm throwing all kind of vowels with him. All right, Mr. Parnell. If I use the modulus in a expression, if I say x is equal to 10 modulus 9, what would x equal to? Yeah. We talking about remainder. So 10 divided by 9 is what? 1, right? With a remainder of what? 1. Right? So no, the remainder is like the whole division. Well, okay. I wish I could write.
9 with a remainder of 1.
Oh.
Yeah, it only holds the remainder. So it divides and holds the remainder. So if I say 6 modulus 2, what's the result? 0. Because when I divide 6 by 2, it's 3 with a remainder of, right. So you understand, that's the modulus. I know they use the modulus sometimes. Now, the modulus in my 192 class, what I do is, because we like, what's the purpose of it? Why we use it? When we do the odd and even number, how do you find out if a number is odd or even? You can do that with that modulus. Take a number, divide it by 2, multiply. All you can do is with the modulus. Take the number, do the modulus of it. Modulus 2, if it's the remainder 0, is even. But the remainder is anything else, it's odd. Right. So that's one way we use the modulus to show you how it works. All right? Okay. So now, what's another one? Punctuation. Every application has its own style of punctuation. I've used Pascal. In Pascal, they use the colon a lot, all right? And when we know C++ use the what? Semicolon. You understand? I think in Pascal you have like x colon is equal to whatever, maybe at semicolon at the end. But C++ is just x equal whatever, semicolon. All right? So every application has its own style of its punctuation, all right? Dealing with a list or whatever, some of them may not use a comma or whatnot. You just list them space, whatever. So it just depends on that application, all right? Then the syntax rules, all right? So that's the rules that govern you as to how you're gonna write that statement, all right? And everyone every application has its own rules that you have to follow. So you might learn one application very, very, very well, all right? And you get on the job and say, well, we want you to learn this language. What you'd have to do is kind of take the concepts of what you know from the one you learn well and apply it to that new language, because there's going to be some things that are different, you know, but at the same time, there are going to be some things that may be similar, all right? But you'd have to kind of cater to what the rules are for that language, all right? Otherwise, you're going to run into all kind of problems, all right? So now, here is a program, all right? So everybody should have, at this time, somewhat written a program, right, class? At least written a C++ program, correct?
Correct.
All right, so I don't know why. Let's see. All right, do it this way. All right. All right, so let's look at this program right quick, all right? So we look at this program. This says that the program calculates a user's pay. Not dealing with overtime or anything, just calculating the pay, right? If you're on a job and you get paid straight time, you work and you work and then you get paid. No overtime. So what are the two main things? Well, not main. What are the two things that are necessary for you to have to calculate a person's total pay? Hours and what? Hours and what? The pay rate. Yes, ma'am.
In the number of hours that they work.
Yeah, that was it. That's hours. Yep, the number of hours and the pay rate. All right. So those are the two things, right? So normally that would have to be something that's given, and then what? The total pay would be calculated, right? So that's the unknown we're trying to solve for. So if we look at this program here, all right? If we want to use variables or user-defined identifiers, we have to do what? Hours, which would be our hours work, correct? Rate, which would be our pay rate. And pay, which would be the total pay. Now, do we have to use hours, rate, and pay in that program? All right, you don't have to. Class, when you're learning programming, try not to be so closed-minded in that, you know, oh, well, this is the way they gave it, so I need to follow. No, this is a user-defined variable. You can call it anything you want, as long as it's followed in the guidelines of those rules. One word, no space. One word, doesn't begin with a number, and no special characters. I could call this just H. It can be kind of confusing if my program is long. I could call this R. And I could call this P. But if I do that, then in my program, wherever I have hours, I'll have to use what? H. Then I have to use R. And then down here, I would have to say P is equal to H times R. And then output what? P, right? Everybody understand that? So whatever that variable is defined up here, it has to match throughout that program if you're using it for that purpose, right? Everybody got it?
Right.
But I could have said hours underscore work. One word. I could have said pay underscore rate. I could have said total underscore pay. Then wherever I did that, well, whatever I have here, I have to match it within my program. Everybody got that? Right? So don't try to be closed-minded. But I would tell you, it's a good practice to make your variables as how would I say it? As meaningful as possible. Because when you start writing larger programs and then you're pulling in data from different functions or whatever, you want to make sure you understand what that variable is without having to what? Try to go to a data dictionary or try to go back to some notes. If you see something that says regular hours worked, you can say, oh, that's regular hours work. You don't have to go back and try to figure out what is hours. You know, what it's hours, the number of hours they work, or that's the overtime, or you understand? So if you kind of make it specific, it makes it much easier to go through the program and debug it. All right? And for somebody to come back behind you and modify it also. Alright, so this program will actually print out you have earned and then whatever that pay is. But if you notice here, we have a command line here that says what? No, yeah, that say see out, right? What we say see out does? Send something to the console. That's console out. That's what it stands for. So we sending something to the console. So it says how many hours did you work? But then right after that we got CN. And what's happening? We actually allowing the user to what? Input a number or whatever, a decimal or whatever into out. Then we follow the same process here. But we know what are these 3 lines here?
The comment?
Comments. That's just to let you know what's going on at that point. That's all that is, just comments. And that kind of helps you and guides you as to what your program is to be doing at that time. Okay? All right. They're not necessary, they're not executed, but they're for your benefit and anybody else who come behind. All right? So normally, most often when you have a C in, it's preceded by a C out. Now, why is that? What?
We have to inform the user what we want.
Correct. Because we'll be sitting down at the computer and the cursor blinking, and we don't know what they want, you know, whether it's a number, a letter, a word, or how, or whatever. And we sitting down thinking, oh, well, the program is just in an infinite loop. No, it's waiting for you to type something. So that's why normally before you have a C in, you have what? A C out that prompts the user and tell them what to do, right? So if you notice here, C out, then C in. C out, then C in, right? So normally that's the pattern, right? But now when you start reading data from a data file, and we'll get to that later on in the semester, you won't need a prompt because what? The system won't need to prompt the system to say input data, right? You're just gonna say read from that data file, you know, get that data from that data file, right? Okay? All right. Now, so we talk about keywords. What are keywords? Reserved words, words that you cannot use as identified within your program. All right, you will get errors. All right. If I try to say, like say int main is equal to 5. What you're trying to do is take the word main. Now you could use a capital M-A-I-N-E, because that's a different word from lowercase M-A-I-N. So if you try to do int and then M-A-I-N equals 5 or something, you will get an error because you cannot assign a value to that function like that. All right? So reserve words, make sure you understand them and know them so that you won't be using them in your program. All right? Now, all it's doing here is trying to break down the program that we just saw. Everybody should pretty much understand what that pound include Iowa stream. You actually load that preprocessor directive. All right, normally there's those libraries for what? Input and output. Right? If you don't have that, you can't do the C out and C in. Okay? All right. Now, and like I say, programmer define identifiers. That's variables or names that you create within the program so that you can write your code. All right. Operators, look, the multiplication. We have equal. Well, you got divide and whatnot. This Russell had talked about exponents. Now, if we're going to use an expression in a program with exponents, we're going to have to load, well, there is one way of doing it, but certain compilers don't use it. Remember that caret? Certain compilers have issues with it. But if we're going to use exponents or whatever, or square root or whatever, we would have to load what library? Huh?
Math.
That math library. That math library has all those functions, tangent, cotangent, all the different math functions that you can use. All right. So what C++ has done, kind of like broken down the library so that you say, okay, I want to read from a data file. I'll have to load that F-stream library. Oh, I want to use vectors, which you'll get to in 194. Oh, you have to load the vector library. All right, so it broke it down to where you don't have to what? Use every single library or every single file or function, you know, and have a big program written to do a small thing. Yes, sir.
Does loading multiple libraries, will that fog and slow down your program?
I think so, because what happens is each time you load it, it has to grab it and put it there. You know, it's not saying, oh, it's already there. No, they keep pulling it in there, and because the reason I say that is when I use it in one place, it's being called by that process. When I use it somewhere else, it's being called by another process. So I think it keep building onto it and adding. You know, that's just my hypothesis about it. Yeah, right. All right. So, line statements. Where we at? Oh, we're talking about punctuation. All right, punctuation. All right, we know that we can what? We can even do say int x, semicolon, int y, semicolon, int z, semicolon. Or I could do what? Int x, comma, y, comma, z, semicolon, right? Because if you look at my website, I think I have, now I'm gonna have to find it, but I think I can find it real quick. If you look here, it shows you in this one, right here, I think it's here. All right, so if we look at this, all right, this gives you the rules of variable names, all right? So this is kind of like extra resources that you can use, you know, when you actually have issues with your programs or whatever, all right? So this what? These are rules for naming variables and which are all what? User programmer identifiers, all right? All right, valid and invalid programmer identifier, all right, or identifiers. Amount underscore paid, valid. Amount space paid, invalid, all right? And we talking about variable name. Phone to, valid. To phone, invalid, all right? So everybody kind of see what's going on. Overtime with capital O, capital T, valid. Dollar sign phone, invalid. No matter what a dollar sign would be placed in here, it would be invalid. Capital C, capital U, and capital T in count, valid. And just camel case, meaning up and down, up and down. All right? So, but then here, this shows you how much space a variable takes up. You might not be interested in this at this time, but as you start writing code and writing larger programs and using up memory and trying to reduce the amount of executable time and all this with your program, the size, this will become important. Give an example. Look at this. We have short, which is integer, of 2 bytes. We have int, which is of 4 bytes. So if we wrote a program, say we was writing some program, dealing with whatever, but anyway, say this was a large program, some program, and all our integers, all our variables dealt with integers, and we made them 4 bytes. But the value of those integers was never less than 32,768 and never greater than 32,767. We could have used short int, which would reduce the amount of space that would be needed for that program to execute. You understand? So that's some of the things that you would look at, you know, later on in your career. But using int, using short, it's still integer. You got what I'm saying? So and then the same thing with float and double. You know, if you have something that you know won't be this large or small or this large, then you would say, okay, well, I'll use float instead of double, because double gonna take up 8 bytes as opposed to float taking up 4 bytes. All right, so those are some of the little things that you can look at later on as you write code. Now look at this, variable declarations. And we're talking about the list. I can write a command. I say char code, semicolon. Right? I'm just declaring what? One variable. I could do that. But if I wanted to declare multiple char variables, then I could say char code, comma, status, comma, switch. semicolon. Well, and switch is a reserve word. I'm about to tell you that. All right. Okay. Now, here we go with int. Same thing. So no matter if it's integer or float or char or whatnot, I could have a single declaration or a multiple declaration. All I have to do is separate it by what? A comma ended in semicolon. But if I wanted to individually declare these variables here, I would say char code what? Semicolon. Char status, semicolon. Char switch, semicolon. You understand? So that's doing them each individually, okay? But I can still do them that way. All right? Then it's showing us expressions. Now, this is one key with expressions, class, and I want you to understand this. Mr. James, you up? Or you just looking at your phone? What you doing? Or you dozing off?
No, I'm up.
All right. All right, here we go. Remember I said you always solve on the right and assign to the left. Always when you're dealing with computers. Always. Solve on the right, assign to the left. And we know in math, we could turn that around and say length time width equal area. And we understand that, correct? But in computer science, the compiler will not understand it. You always assign the value to the left, all right? Look here, give an example. Area equal 30. It's not an expression, but this is a constant, right? A value. We're taking that 30 and what? Assigning it to the left side, which is a variable called area, right? But if I reverse that and say 30 is equal to area, I'm trying to overwrite 30, and 30 is constant. 30 is 30 is 30 is 30, right? So you can't change that, all right? How many people have written a program using constant variables? Okay, when you use constant variables, it's just like saying that variable is this value and it will not change throughout this program. And if you try to change it, even if you try to give it the same value, you will get an error because it's a violation. You trying to take a variable that you said won't change and trying to change it, all right? Cannot do it. You will get an error, all right? Now let's talk about data conflicts. Now this here in C++ is somewhat true, but you gotta watch what you're doing depending on what's going on. All right, you got char code, int, age, float, amount. My numeric values, I can assign them to each other, all right? Age is int, this is float, I can put age into a float variable, all right? Amount is float, age is int, I can take that float value and put into an int variable. But what happens when I do that? I lose what? I lose the decimal size, okay? So if amount is 23.8 and I'm storing it in the age which is integer, all that's gonna be stored in the age is what? 23. It's gonna throw away the rest, okay? You gotta remember that. But look here, violation. Age is equal to code. Now, what happens here, C++ has a way of taking age, which is an integer, and assigning it to code and converting it to that char value. So you gotta watch it. But what I'm saying, if you're writing code, normally that's not stuff you want to do unless you're doing some specific thing. So you gotta watch, right? Code is equal to amount, same difference. You just gotta watch what's going on. You don't want to store that char value into amount, right? So you gotta watch it. Code is equal to age, same difference. So just some things you gotta just watch, all right? Can be done, but you wanna watch that. All right, so let's go back to the note. So that's dealing with the punctuation. We saw what happened, all right? All right, now, line statements, all right? Boy, let's say statements by line. So it what? It started with CI, ended with a what? A semicolon, right? All lines will not end in semicolons. Everybody understand that, right? If I have a function name, like int main, main will not have a semicolon at the end of the parentheses, correct?
Correct.
Because if you do that, you're closing off everything saying that's all I'm doing for the main. right? Main has a body. An open curly brace, you don't put a semicolon. Closed curly brace, you don't put a semicolon. All right? But most of your statements inside, depending if statement, you don't put a semicolon because you have a body, correct? And on your statements within the body, you would have your semicolon. All right? So you gotta watch that. All right? And like I said, we just talked about variable names. Now, with variable names, all that happens is when I declare a variable, if I say int x, what the compiler does is says, okay, I need to create a variable. So it goes to the computer and say, hey, I need to create this variable called x of integer. So the computer says, okay, I have this memory location. I'll label it as x, and then whatever value you put in x will be stored in that memory location, so that you can always call on that value, by referencing x and using it. Later on, you're gonna understand how you can use pointers, and that's in 194, and actually reference that information. All right. So basically, that's all it's telling you. When it did the value of variable length, it says, okay, let me go to this address. I'll put this value in it, and whenever I want to retrieve it, I'll go to that address and pull that value from that address. All right. Variable definitions. All right. In the program, in programming, there are two general data types. All right, types of data: numbers and characters. All right. Numbers are used to perform mathematical operations. All right, and characters are used to print data on screen or on paper. All right. Numeric data can be categorized even further. All right. Into the following whole numbers which is integers, and then you have floating point numbers. All right. So you have what? Character data, numeric data. Numeric data can be further broken down into a floating point variable or an integer variable. All right. Or integer data. All right. So that's all it's saying here. All right. Now, okay, when creating a variable in C++, in a C++ program, you must know the data. You must know the type of data the program will be storing it in. And like I say, when you allocate that space, if I allocate a space, how you doing, to be an integer, and then I try to put in 2.5, it's gonna only put what? 2. So you got to know that data type and what you want to put in. Yes, ma'am, you got it? Oh, okay. Yes, ma'am, new semester. Yes, ma'am. All right, so you got to know what's going on. All right. Now, input, processing, and output. This is the primary function of a computer, right? Data is being inputted, data is processed, and then data is output. Simple as that. That's what a computer actually does. Now, sometimes it does multiple inputs before it processes and output, or one input, multiple processes, then output, or a single input, single output, and multiple outputs. But it depends. But basically, input, process, and output. All right. So the computer programs typically perform a 3-step process of gathering input, performing some process on the information gathered, and then producing output. So basically, that's what it is. Inputting data, what's the command we use?
CN.
CN. Everybody got that? You'll see it. Now, outputting data, well, let's go before we output. Processing data, normally we use our mathematical expressions, right? Like our modulus, add, multiplication, division, right? And that would be somewhat like this. Pay is equal to hours time rate. That's processing, all right? But then we have what? Output. So input, process, output. That's basically what a computer does, all right? So, designing and creating a program. Now, class, many people in the class gonna do it many different ways. Some people gonna call somebody, hey, you got this? How did you go about doing it? Get the answer or whatever and don't know what to do. It's gonna happen. But I would tell you to understand it for yourself. I'm not saying not to get help, but I'm saying understand it for yourself. All right? Look, they give a list of things that you should do. All right? And the very first one, right? All right? You should clearly define the program, all right, or what the program is to do. All right? I'll give you an example. If I told you I needed you to find the volume of a cylinder, right? I don't know the formula. You might know it, you might not know it. But what's the first thing you're gonna try to do before you write a program?
Look up, if you don't know the formula, look it up.
Look up that formula to see what all it consists of, so I kind of have some idea of what I need to be doing, right? Not just go there, let me write this, and I'm gonna just throw something. No, you got to know exactly what it is you need to do before you start doing something. Otherwise, you're gonna be what? Starting over, doing something, starting over, doing something again, starting over. So knowing what to do, that's one of the key things. Another thing you should do, or should be able to do, is visualize the program and what it's to be doing. Because what? If I can visually see that, if I say, okay, you need to input the values for the cylinder and whatever, you need to visualize, okay, what I want to prompt the user, you know? How I want it to look, where I want it to be located, how, you understand how many steps? So you should be able to have some kind of visual of what it is you want to type up, rather than try to type in something and like, oh, well, my number came out, but it's represented wrong. Now I got to go try to research and try to figure out the format, whatever. When you could have done all that at the beginning and wrote your program and bam, it's done. But, like I say, it's up to you. But these are some things. Use design tools such as hierarchy charts, and a hierarchy chart is used pretty much for functions. If you have multiple functions that work with that main function. All right? Flow charts, write out your flow chart, or pseudocode. Write them step-by-step things that you might need to do. And I'm gonna tell you, as humans, what we do, we overlook a lot of things because what? We take for granted something has happened. When we do math problems, right? If we have something where we add 2 plus 2, we think, well, I know 2 plus 2 is 4, right? We don't show it or do whatever. But if we're doing something with the computer where we have to add 2 and 2, we have to do it. Because the computer will not just say, oh, I know 2 plus 2 is 4. We have to compute it, and store it, and then use it, right? So we can't be so, how would I say, be so the way we think the computer should know this. You are the computer. You are the one designing it. So, and a lot of times I would do this. If you had a little brother or somebody who's a novice at computers, I'd write my code and let them run it. And then, because a lot of times they'll give you more insight than you saying, oh, well, it's working. I read, because sometimes you read through a message, not reading what it's saying, thinking you understand it, and you let somebody else get to it, and they say, input your data. And they put in a letter A when it should have been a number. You understand? And then like, oh, I'm gonna change it. Please input a whole number. You got what I'm saying? Stuff like that. But we be thinking like, oh, I got it. It's running. You're supposed to input a number. No. The user will only what? Do what is instructed. Correct? So you got to make sure it's legible. Got to make sure it's visually it's proper. Because I do take off a lot of times with students. Put an output line and a number is right next to the label. Space it out so it's more readable, right? Right, class? You in the class, man?
No, I think I was looking. I was like, anyone seem like a wallet, round one, maybe?
Check. I think this is the first class today, though, huh?
Oh, that's wonderful.
You got it, huh?
Wow.
See, we on it, man.
I just always sometimes.
But you could have asked, though.
I did.
You win. I'm saying, Mr. Professor, can I come in and check?
Oh, Mr. Sylvester.
Too late now. Right? He could have asked, Hey, it's all right. He got it. That's a good one. He got it. All right. But I'm saying, those are some of the things. Now, you gotta type your code, you gotta run the code and all this, and then check for error. Sometimes you may have to repeat. Why? Because what? You might have a syntax error. Then once you get all the syntax errors, you might have a logical error. Then you take out all the logical errors, you might have an error, not saying an error, but you might have it to where my display is not just right. I need to position my data in a different fashion. All right? So there's many different things that you have to consider. All right? All right? And like I say, this is another thing that students don't do most of the time on several levels. Number one, if I ask you to take two numbers, multiply them, and print it out, and like I said, if I give you a large number that pretty much you can't compute in your head, some students will say, okay, I got output, I'm finished. And then when I run it and they get the wrong data and I give you a 0, well, Mrs. Vester, it worked. The program worked, but it didn't give me the right results, right? And you didn't check to see whether you was adding or multiplying or dividing or whatever. You got it? So you got to make sure what? You test the data to see if your program is actually doing what it's supposed to be doing. Don't just take for granted that because you got output, oh, my program working, all right? Another thing, when we get to if statements, all right? A lot of times with if statements, you might have two different choices or two different things you might have to do. Give me an example. If I say input 5 numbers, all right? Calculate the average, okay? If the average of the numbers is greater than or equal to 80, tell them great job. Otherwise, tell them see you next year, all right? Simple as that. Now, somebody write the program and says, okay, if average is greater than 80, right? So they forgot what? The equal, correct? So they test 90. Oh, it works. So they check 50. Oh, it works. But then I put in the 80, and it's still doing, it's not giving me the right result. You got what I'm saying? So you checked it, but you didn't fully check it to see if the program actually worked. All right? So that's some of the things you got to watch when you write code. Make sure you go back and check it and test for all conditions to make sure that it is doing what the instructor said it's supposed to do. Because when you're out there, if you're working for a company or if you have your own company and you're developing software, a penny here, a penny there, $1 or $10 here, there, over time can cost you what? Cost you millions of dollars, right? Until you catch the problem, you understand? So you got to make sure you test to make sure that information is being executed properly. All right? So, and then here it goes through the motion of explaining each one of those in the list, so you can read that for yourself because it's basically telling us what we talked about. All right? Now, so this is a hierarchy, yeah. So this is a hierarchy chart. If we look at this hierarchy chart, which we never got into functions yet, I think my class last semester we talked about functions in chapter 3. But if you look at this, this is an example of a hierarchy chart. What this hierarchy chart shows is that information here is being calculated for gross pay. So that's a function, okay? But that function has 3 different calls in it, okay? So in this calculate gross pay function, it's going to have a function that actually get the information from the user, return back here. Then it's going to calculate, let's say get what? Get payroll data. So that's the rate and the hours, all right? So it's going to get the rate and the hours from the user, all right, and return. Then it's going to call this function, and then it's going to multiply the values. Then it returns, and then it displays the gross pay, all right? Then it returns. But look here. Before it, when it actually calls this function calls 2 other functions. Calls this function to get the number for the hours work. Then this one call the function. Is it time?
We got like 3 minutes. I just gotta get skipping real quick.
Oh, split up game. Alright, so and this one calls a function here and then code return back here, then we return back here. So it's just showing you how the functions are being manipulated in that program. Alright? Now, let's see here. And like I said, it's showing them okay, what is software engineering? Basically, software engineering is all of what that list was about. Understanding the problem, researching and going about getting it written out and logically put in steps, etc. That's really our software engineering class. So it's saying the field of software engineering encompasses the whole process of crafting computer software. So when you go through the steps of saying, okay, I have this issue that for a program I have to solve, and you go through those steps, software engineering, okay? That's what it is. However you go about doing it, it's software engineering, all right? Procedural logs, okay. Well, let's see where we at. Oh yeah, we're at the end. So, here we go. So that's software engineering. So, procedural programming and object-oriented programming. Procedural programming, all right, normally you have programs, okay, I have this information, this information, this information, and you're doing it by procedure. Object-oriented is where normally I could create a class, another class, and within these classes, it's different variables and whatever, and they call them methods and instances. You create instances from those methods, and then you call using those objects to manipulate your program. So that's object-oriented. But you're getting the object-oriented in 194. In 193, 2, and 3, we're doing procedural programming. All right? So it's a C++ programming language. C++ is a language that can be used for two methods of writing programming, computer program. Procedural programming and object-oriented programming. All right? So what I'm going to do, class, I need to do it for the other class too. I need to post the test. I'll post the test from today, which is what, Thursday, until?
No, today Wednesday.
Wednesday, yeah. From today till next Wednesday. All right. How many people plan to take it on Proctor U? Because I need to put it out there for those people. But
you got to pay for Proctor U.
Yeah, you pay for Proctor U. But you can schedule it here in the testing center. Make sure you schedule it in a timely manner, because you don't want to wait till the last minute and they booked up and it's like, oh, Mr. Sylvester, I tried to schedule a test and there was no time slot.
Could you schedule it online without going over there?
Right. You can like say you want to say I'm gonna take it on Friday because I only have one class and I'm all whatever. So you could schedule it today for Friday. You don't have to wait till Friday to schedule. You understand? You can schedule it ahead of time. All right. So class,
I'll schedule as soon as I get home.
We're looking online for assignment. All right. Make a little program that I want you to write up. All right. How many people have not successfully installed the visual? All right. What's the problem? Like I say, you can use the online GDP. Oh, okay. Yo, what you got?
I just installed it now.
Oh, it took that long. But by the time it loaded, it was too late to submit it.
It really was. Like that day you came, I was like, that was the first time I really, because I went to sleep.
What test?
Yeah, the test that he was talking
Yeah,
about.
test. I'm gonna post it. Test 1. It'll be a test on chapter 1.
Okay. Oh, I'm thinking. I thought he was talking about it.
Now you gotta take it in the testing center now.
It's just on chapter 1?
Yeah, I always do chapter by chapter.
That's last week's assignment.
Uh-huh.
Program 1, for some reason,